You know, if you wear glasses or contacts, you've got a prescription with a little number on it. It's a number that literally changes how you see the entire world. But have you ever stopped to wonder what it actually means? All right, let's dive in and crack the code on one of the most important and honestly, surprisingly simple units in all of optics. So you glance at that prescription and you see something like, I don't know, -2.5 or maybe a +1. What in the world is that measuring? Is it like a percentage of bad vision, some kind of secret code for opticians? Well, it's actually a measurement of power. And once you get it, you are seriously going to see the world in a whole new light. Let's just take a number like this one, -2.50. This little number tells an expert exactly how to bend light to make your vision crystal clear. And the key to unlocking what it means is a single, really elegant concept that was standardized over 100 years ago. And yep, that concept is the diopter. This is it, the fundamental unit of optical power. It's the language that everyone from your eye doctor to a camera designer speaks. So what exactly is it? Okay, don't let the word reciprocal throw you off. I promise it's way simpler than it sounds. A diopter is just 1 divided by the focal length of a lens. And this is the important part. That focal length has to be in meters. That's it. It's this beautiful metric-based way to talk about just how much oomph a lens has to bend light. And this right here just lays it all out perfectly. A pretty weak 1 diopter lens, it takes a full meter to bring light into focus. But a more powerful 2 diopter lens, it gets the job done in half the distance, just half a meter. So the main thing to remember is this. The bigger the diopter number, the more powerful the lens is, and the shorter its focal length is going to be. Simple as that. Now, this whole system wasn't just invented overnight. The idea was first kicked around way back in 1866, and then in 1872, a French ophthalmologist named Ferdinand Monnoyer officially gave it the name diopter. And this simple, logical system caught on like wildfire for one very, very practical reason, one that makes an eye doctor's job so much easier. And here is the diopter's superpower. You can just add them up. It's true. If an eye doctor is trying to find your perfect prescription by combining different lenses, they don't need some crazy complicated formula. A 2 diopter lens plus a half diopter lens is a 2.5 diopter lens. It's simple, it's practical, and it's just brilliant. All right, now that we've got the basics down, let's talk about the most amazing optical device you'll ever own, your own eye. How much power is actually packed inside your head? You know, the answer might just blow you away. Get this, a totally relaxed human eye has about 60 diopters of focusing power. 60! That is an incredible amount. It's like having a built-in lens that can focus light at just over 1.5 centimeters away. It's an absolute powerhouse of biological engineering. So where does all that power come from? Well, this chart breaks it down for us. About 2/3 of the work, a massive 40 diopters, is done by your cornea. That's the clear front surface of your eye. The other third, about 20 diopters, comes from the lens inside your eye, the part that actually flexes and changes shape to let you focus on things up close and far away.
So, when our vision isn't perfect, it's usually because the eye's power doesn't quite match its length. If you're nearsighted, the light focuses too soon, in front of the retina. The fix? A negative diopter lens, which kind of spreads the light out just a little bit before it hits your eye. And if you're farsighted, the light tries to focus behind the retina. The solution there is a positive lens, to give the light an extra little push to focus correctly.
And this really helps put those prescription numbers into perspective, right? A super common prescription for nearsightedness falls right in that -0.5 to -3 range. And those reading glasses you see at the pharmacy, they're typically between +1 and +4. It's pretty amazing to think that a tiny change, even just a quarter of a diopter, can be the difference between a blurry mess and seeing a street sign perfectly. That's the kind of precision we're talking about.
But here's the thing. The diopter's job doesn't end with your glasses. This super fundamental unit of optics actually pops up in a few other places you might recognize.
So if you've ever used a big DSLR or a mirrorless camera, you've probably seen this little wheel right next to the viewfinder. Well, guess what? That is a diopter adjustment. It lets you literally tune the viewfinder's optics to your own prescription so you can look through it and see a perfectly sharp image even without wearing your glasses. Pretty cool, huh? So you see, this is way bigger than just vision. The power of a magnifying glass is directly tied to its diopters. And physicists and engineers even use diopters to measure the exact curvature of a lens or a mirror. It really is a universal language for bending light.
Okay, wow, we have covered a lot of ground, from a simple definition all the way to the optical powerhouse sitting inside your own head. So let's bring it all into focus and wrap up with the most important takeaways.
If you only remember 4 things, make it these. 1. A diopter is just 1 divided by the focal length in meters. 2. Your eye is an incredibly powerful 60 diopter system. 3. Negative numbers on your prescription are for nearsightedness, positive numbers are for farsightedness, and 4. This simple unit is the absolute backbone of practical optics.
So the next time you see a camera or a magnifying glass, or even just your own glasses prescription, you'll know the secret. You'll know it's all about one simple question. At what distance, in meters, does this lens bring the world into focus? It's a completely new way to understand the very act of seeing.